All right, for the second part of indirect measure, we're going to look at a real-world example of how you might use similar triangles to indirectly measure the height of an object. So let's say you go outside at some point later today when it's a little more sunny, and you are outside and you're looking at trying to measure an object that is much too tall to measure with a ruler or a measuring tape or something like that. You can actually use the idea of similar triangles to measure an object. All right, so let's say you go outside on a sunny day. All right, here's you standing outside on a sunny day. So when you are outside and the sun, right, the sun's rays are hitting you, this causes you to have a shadow. Okay, so let's say you're standing next to a big old tree that is much too tall to measure with any sort of standard instrument. The way that the sun is hitting you is hitting this tree at the same exact angle. So because of that, right, the tree's going to have a shadow as well. But because the angle at which the sun is hitting you is the same as the angle at which the sun is hitting this tree, you and the tree are actually forming similar triangles. So it may not look like we have a triangle just yet, but the angle at which the sun's rays are hitting you gives us the third side of our triangles. And because the angle that the sun is hitting you is the same as the angle that the sun is hitting the tree, you and that tree, or you and any object in the same relative location on Earth, are forming a similar triangle. What that means is that your height is proportional to the tree's height. And the big piece here is that your shadow is proportional to the object shadow as well. So while you may not be able to get up and climb a tree with a measuring tape and directly measure the height of the tree, something you would be able to do is actually measure the height of the shadow. All right, so let's use me for an example. I know that I am 6 feet tall. Okay, so let's say I go outside and I measure my shadow. And let's say my shadow that I was casting was approximately 10 feet in length. In order to indirectly solve for the height of the tree, all we would need to do is measure the length of the tree's shadow. We would then have enough information to set up a proportion and indirectly measure the height of the tree. All right, so let's say we go measure this tree's shadow. And let's say that the tree's shadow is 25 feet long. We now actually have enough information to solve for the height of the tree. So we're going to set up the height of the object over the height of the, or the length of the shadow. So my height, 6 feet, over my shadow, 10 feet, is equal to the height of the tree, which we're trying to solve for, over the length of the tree's shadow, which is 25 feet. We now have a proportion that we can use one or two of our different methods to solve. Okay, first things first, we can look for a constant factor. 10 to 25, there's not a direct constant factor there. So you've got two other options. Remember, you can cross multiply. So let's go ahead and do that. So our first cross product would be 6 times 25 equals our second cross product, which is 10 times the height of the object. So if we take 6 times 25, we would get 150 feet equals 10 times our mystery number. So now to solve for our mystery number, we'd take 150 divided by 10, and we'd figure out that the height of the tree is 15 feet. Let's check that slightly easier way of doing this. We can actually reduce 6/10 down to 3/5, set that equal to the height of the tree over the length of the shadow. Now we have a constant factor. 5 to 25 is times 5. And then if we take 3 times our constant factor of 5, we'd figure out that the height of the tree is also 15 feet. So the key to this working is that when you are in the same relative location on Earth, the sun is so high up in the sky that it's hitting all of the objects in your general area at the same angle. Because the angle of the sun's rays is the same for both objects, you and any object in the same general area are actually proportional to each other. So if you can measure your height, the length of your shadow, you can indirectly measure the height of a much taller object by measuring the object's shadow and then setting up a proportion and solving accordingly. So if you got time today, if the sun comes out a little bit more, you could actually go in your backyard and practice this. Measure your height, get a parent to help you measure the length of your shadow, measure the length of a shadow of a much, much taller object or a shorter object as well if you want to prove that this works. And then using a proportion, you can indirectly solve for the height of an object using this idea of similar triangles.